Here is page 11, and we're going to start solving rational expressions. So meaning that when we're solving, you should see an equal sign, and we're actually looking for x, meaning we want to get x by itself. And when we do this, we want to eliminate the denominators by multiplying by a common term. And then you must also remember to check for extraneous solutions, meaning once we do all of these steps and you get x by itself, you gotta plug that number back in for your x and see if your left side actually does equals your right side. Okay, so to start off, what we like to do is we would like to have a fraction on the left side, so a over b equal to a fraction over equal to a fraction on the right side. So like you can have x in the numerator or denominator over c. Okay, and when we have it like this, we're going to cross multiply. We're going to do a times c equals b times x, and then you would solve for x from there. Okay, so when we are doing this, so notice that I have a fraction here, but I don't have one fraction here, so I need to put these two together first. So I'm going to put a common denominator. So this is right now over 1, and then I have a 3 here, so I'm going to multiply top and bottom by 3. So you have 1 over 3 equals 1 times 3 is 3 over 3. And then I'm going to bring this part down. 2x minus 12 over 3. Now I have a common denominator here, so I can go ahead and put these two to the numerators together. So I'm still going to have this. So you have 3 plus 2x minus 12, so we're going to combine the like terms. So that would be 3 minus 12, that would be negative 9. So I'm going to bring down the 2x, and 3 minus 12 is negative 9 over, and then bring down the common denominator. Now here we have two options. Well, the first, like the technical way, what I did here was cross multiply. So you would do 1 times 3, which is equal to 3, and then 3 times all of this. So you would do 3 times 2x minus 9, and then here we can distribute the 3, so you have 3 equals 6x minus 3 times 9 is 27, and then just keep solving. So 27 plus 3 is 30 equals 6x. Divide by 6, divide by 6, you have x equals 5. Okay, and then over here, yeah, and then now just make sure you check for extraneous solutions, and so you would take this and plug it back in your original. So let me erase all of this. Plug it back in your original to see if your left side equals the right side. And the best way to do this is in Desmos. So I'm going to go to Desmos. Okay. So I'm going to put the right side. Well, the right side is just 1 over 3, which is just 1 over 3. There's nothing but that. And you have 1 plus, and then I'm going to hit divided by, and then I'm going to put 2, and inside of my x I'm going to plug in 5 to check, minus 12 over 3. See, that worked, because the left hand side, which is 133, equals my right hand side, which is also 1 over 3, and 0.33, same answer. So this is checked. Now I did say that you had two options here. So right here, the other option was if you have the same thing in the denominator here, and it's only, there's only one fraction here, one fraction here, and then you have 3 over 3, you can actually just take out the denominators and set the numerator equal to 0. So another way could have been 1 equals 2x minus 9, and then you could have just solved it this way. So that's 10 equals 2x, and x equals 5. So you would have got the same answer that way as well. Okay? Alright, so this one right here, we have 1 over n plus 1 over n squared equals 4 over n squared. So I need to make this into one fraction by adding these two. So to get a common denominator here, I have n here and I have n squared. So here I would just multiply both numerator and denominator by n. So you would have 1 times n, which is just n, and then n times n is n squared, which is exactly what I want over here. Okay, and then so here I can just put the numerators together. So n plus 1 is just n plus 1. I cannot combine those. And so this is the different method I was talking about. So like if you have the same thing in the denominator, you can just cross them out and just set the numerator equal to each other. So n plus 1 equals 4. And then now I can solve this. Minus 1, minus 1. So you have n equals 3. Before I say this is it, I have to check it. I have to plug it back in here. Okay. So I'm going to do that in Desmos. Okay. Alright, so here's my left side. So you have 1 over n, 1 over n, and instead of n, I'm going to plug in 3. So I'm going to put 1 over 3 plus 1 over n squared. So that means that is 3 squared. And that's the left hand side. We'll see that it's this one right here. Let me check on the right hand side if I get the same answer when I plug in 3 and for n. Yeah, see? I get the same thing. So that works. Alright, so for this one, number 3, so we have here, so we have 1 over x plus 2, x minus 2, plus 1 over x plus 2 equals 6 over x plus 2, x minus 2. So I have two fractions here. I need to combine these two to get one fraction. I need to have a common denominator. This denominator has an x plus and an x plus, but it doesn't have an x minus 2 here. So I'm going to go ahead and do x minus 2. So you have here 1 over x plus 2, x minus 2, plus, and then 1 times n minus 2 is just n minus 2 over, and then you have all of this equals, and then you have 6 over x plus 2, and then you have n x minus 2 here. Okay. And so in the numerator, you have 1 plus n minus 2, so that's just 1 minus 2. So you're going to bring down that n. 1 minus 2 is negative 1 over, why am I keep writing n? It should be x. My bad. Okay, bring that over. Equals 6 over all of this. Okay, so now let's check if we have the same thing in the denominator. Yes, so which means that I can cross those out and I can set equal to the numerator, x minus 1 equals 6. And then now I can keep solving. So x equals 7. Okay, before I can check and say this is correct, I need to plug it back in and see if this actually even matches. Okay, the left side doesn't equal the right side. So let me go ahead and put it in Desmos. So what I'm going to do is I'm going to plug this in, but for my x's, I'm going to plug in the 7 to check. Okay, so I have 1 over x, which is 7 plus 2, and then 7 minus 2, okay, and then plus 1 over x plus 2, so that's 7 plus 2. And I have this right here. You can put it in decimal form or fraction, it doesn't matter. And then now we're going to check to see if the right side we get the same thing when I plug in 7. So you have 6 over, and then you have 7 plus 2, 7 minus 2. And it didn't work. Let me make sure I did everything correctly. Okay, yeah, well, wait, did it? Oh, yeah, yes. Oh my goodness, yes, it did work. They are equal. So this checks out. I do want to show you something else in Desmos with equations. Sometimes it does, if there is a solution, and if you plug in the original, let me change all the x's back to 7. I mean, x7's back to x's equals, and then if you put in the right side, if you put in the entire problem by itself, it does, you know, show you what the answer is. Okay, so here's my original equation right here. Okay, and then it says that the answer is right here. So if I zoom in, it actually puts a red line right there. Okay, so that's one way you can also check your answers. Okay. All right, so for this one, we're gonna have to first find a common denominator, then cross multiply. So over here we have to put these two together. So this has an x squared and this has an x squared, but this has an x and this doesn't. So I mean a 6. So I'm gonna put a 6 here. Okay, so that would be, so I'm going to distribute it. So 6 times x is 6x. 6 times negative 2 is negative 12 over 6x squared plus, and then I'm going to bring that down. Now that I have the same denominator, I can now add my numerator. So 6x, negative 12 plus 1 is negative 11. Okay, now they don't have a common denominator here, so I cannot just cross it out. Again, you have two options. Either you can make this look like this, so for example, you can multiply this by 3, so then you would have 3 over 6x squared equals 6x minus 11 over 6x squared. And then now I can cross these out and then put the numerators to equal to each other. 3 equals 6x minus 11. That would be 14 equals 6x divided by 6. So x equals 14 over 6, which is equal to 7 over 3, because 2 goes into 14 7 times and 2 goes into 6 3 times. Okay? Now before I say this is the answer, let me go ahead and plug it back in the original and to check if it works. Okay, so I'm going to do this part in Desmos. Alright, so we have here the left side, which is 1 over 2x. So 1 over 2. And sometimes when I'm plugging something in for x, I know that I have to put it in parentheses, especially if there's like a square at the top. So make sure to put that part in parentheses. Anyway, I'm checking if it's 7 over 3. And then that is being squared. Okay. And then So that's my left side. Now let me check my right hand side. On my right hand side I had x minus 2, so I have here, let me put my division bar, it's kind of hard to see. So there's my original, so you have x minus 2. And here's another trick you can do. So like if you don't feel comfortable putting it in the x the way it is, sometimes I put like an uppercase x, and I'll show you why. So you have uppercase x minus 2 over uppercase x squared plus, and the reason I use uppercase is when I use uppercase, then it gives me the slider, and then I can just plug in a number for that slider. So 1 over 6x squared, we can add a slider, and then I'm going to, now my x, I'm saying is equal to 7 over 3. So let me change that to 7 over 3. And I did not get the right answer. 2 using physics. Okay. Oh, sorry. This is my answer, right? So here it is. I think that's a little confusing. Let me just change the x here to 7 over 3. Okay. Then change that. 7 over 3 squared, and this is 7 over 3. There we go. Yep, both of the sides equal to each other when I plugged in 7 over 3 into all of my x's here. Okay, and so that equals each other, which means it is correct. Okay, 2 more problems. So right here, I need to have a common denominator to put these two together. So I'm going to put an x in the numerator and denominator. So 1 times x is just x over x squared minus 1 over x squared, and then bring everything else down. Okay, so now you can put the numerators together since I have the common denominator. X minus 1 is just x minus 1 equals 3 over x squared. Now I have the same thing. I can put the numerators together. X equals 4. Now let's check and make sure that 4 does work. And let me try to check it a different way this time. So let me go ahead and plug in this entire thing in here. Let me graph it. 1 over x. And now I don't have to change this x to anything because I'm actually going to graph my answer here. Equals 3 over x squared. Alright, so I'm checking to see if it's 4. So I'm going to press the home button and then just check if it's 4. Yes, drew that line right there, which is 4. Okay, so over here, I need to get a common term. So this has a 3m and this has a 6m squared. So this one needs a 2 to make it a 6. Okay. And then also I need, and this one has 2 m's and this one only has 1 m. So actually I'm going to make this into 2m. So that if I do 2 times 3, I get 6. M times m, I get m squared, which is what I wanted. So 2m plus times 1 is 2m. And then you have 1 over 6m squared. And then here, since it'll be nice to have the same thing on all of my denominators, this is missing an m, so I can go ahead and put an m here too. So you have 1 times m, which is m. And then you have here 6m times m, which is 6m squared. Alright, so now I can put the numerators together. So 2m plus 1 is just 2m plus 1 over 6m squared equals m over 6m squared. Take off the denominators. You have 2m plus 1 equals m. All right, so I'm going to move this over here. So you have 1 equals m minus 2 have 2m, 1 minus 2 is that's negative 1 m. So take that negative 1 over. So that's negative 1 equals m. Let me go ahead and plug in this here. Now, if you want to check your answer for this one right here, okay, you need, and you want to just do it by graphing. Whenever in Desmos you want to graph this, you need to use an x. So I'm going to change this into an x so I can graph it this time. So you have 1 over 3x plus 1 over 6x squared equals 1, equals 1 over 6x. Okay, so we were saying m is equal to negative 1. And yes, it is. M is equal to negative 1. Now, if I did put an m here instead of an x, if I use the m, it doesn't graph it for you. It actually does nothing. Okay? But if you want to check it using m, then you have to add a slider, and then you're saying that m is equal to negative 1 to change this to negative 1. And then now put in the other side, so you have 1 over 6m, and then these should match up. Okay, if you're not graphing, then you have to match up the decimals. Okay. Okay, so on the next page here, we have some multiple choice question equations for you, and we do have some choices. So what you can do is, if you want to, if graphing is you like graphing it on Desmos, you can do it that way, that's fine. But just remember that when you're graphing, you need to make sure to use x. So if you have 2 over 3x equals 1 over 6x plus 1 over 3x squared. Okay, just check it real quick. Okay, press home. And then, so the thing with this method is like it gives you like a decimal. Okay, I mean, if you want, and since it's a multiple choice, I mean, it cannot be C and D, it has to be between these two. I would think it's 2 over 3. Let's check. 2 over 3 is about 0.66, which seems like that matches this. Okay, so I would pick A. Okay, so that's how you can do some practice problems on this.